Hello, connected viewers. My name is Karl Johnson. I'm the meeting program chair for the 2018 AIChE annual meeting. I'm also the W.K. Whiteford professor and associate director of the Center for Research Computing at the University of Pittsburgh. And we are here today at the University of Pittsburgh, and I have the great pleasure of interviewing my two distinguished guests, Kamel Ben-Naceur, the former director of the International Energy Agency, and currently the chief economist at ADNOC, and T.J. Wojnar, the vice president of corporate and strategic planning at the ExxonMobil Corporation. And I'd like to welcome them very much. They were plenary speakers in the session, The Future of Energy in the Region, Nation, and World, at the annual meeting here in Pittsburgh, 2018. Thank you again for joining us today.
Thank you.
Thank you.
Kamel, my first question is for you. What are the technological advances needed to create a long-term sustainable energy future?
Good morning to the connected viewers. The world needs more energy. One is to fuel the needs of the over 1 billion people that don't have access to electricity today, and over 3 billion people that don't have access to modern energy sources. So starting from that, we need to also fuel economic growth, and energy plays a very critical role there. How do we get there? If we look at the scenarios of doing the same as we are doing today, we get to unsustainable scenarios. And essentially what we need to do is take a number of measures, develop a number of technologies that will take us to a much more sustainable energy future. So what does it mean? Number one is have much less emissions than what we have today, the greenhouse gas emissions. The second thing is to use much more efficiently the energy than we are using it today. So if we put it in terms of what it would take in the future, one is we need to have a much lower carbon footprint. How do we get there? First thing is we need to switch from the very large CO2 emitting energy sources to much more renewables. So renewable will play a key role. The second one is moving into a much more efficient energy use. So these would be the principal wedges of decarbonization going forward. A third one is going to carbon capture, utilization and storage, and also a number of other new sources of energy, moving to hydrogen and others. So what does it take in terms of technology? One, we need to have much more investment in new energy technologies than we have today. We are still very far from what other sectors are spending. If we compare it to the IT sector, the energy sector, especially given its size in the economy, does not spend enough. So this is an appeal for the energy sector to spend more, and also to public sector to spend more money on the modern energy sources.
TJ, I'd like to follow up with one question. If you could pick one technology that is of most need to accomplish this sustainable energy future, what would it be?
Well, zero carbon sources, solar and wind, are a key piece of this energy transition that Kamel talked about. But they can only penetrate so far until you have grid storage, the ability to store those electrons when the sun's not shining or the wind's not blowing. Without that, you can only penetrate so far into the grid, and that's a very difficult technical challenge. So for the bright people in this industry that are thinking about where to do R&D, that's one that would really make a big difference if we're able to get it. It's a tough problem, but it will have a huge impact.
Energy storage is the name of the game. Let me follow up then with another question, changing gears here. In this area, we have a lot of shale gas. And so, TJ, what do you think the impact of shale gas will be on the energy and petrochemical landscapes over the next few decades?
So if you look broadly at unconventionals, so oil and gas, this has been the biggest transition in this industry, perhaps globally, certainly in the United States. It's moved this country from being a net importer to likely a net exporter of both oil and gas. And it's a huge impact in this region. It's a huge impact on the US Gulf Coast. And any industry in this country that consumes a lot of energy has global competitiveness because of the strong economics that are available actually for both oil and gas. The resurgence of the petrochemical industry, one of our IOC competitors is building a facility right here close to this area based on that shale gas. So petrochemicals, clearly a big opportunity. Also the export of liquefied natural gas, something that people didn't really see. We were building LNG import terminals 15 years ago. We missed this trend a little bit, but it's a huge trend and a really big deal. Particularly gas as a transition fuel for the transition to another economy, just has a better CO2 footprint than other alternatives until such time as we're able to get perhaps fully onto renewables with things like grid storage.
All right. So it's a technology that we didn't see, or an advent that we didn't see a few years ago, and now it's making a big impact for us.
It is. You know, I get asked the question, I produce our energy outlook, and hey, we missed this trend in the early days. So we think a lot about that because we don't want to miss another one. But it's been a really big boon for this country and for the regions where this resource is available.
Okay, I'd like to finish up with one question for both of you. Thinking about our young chemical engineers who are watching this, what's the best way that chemical engineers can positively impact the energy future? Kamel, maybe we'll start with you.
So I would say they need to think about designing things for sustainability. They need to design things for reuse. They need to design things for low carbon footprint. This is a key requirement going forward.
TJ?
Yeah, I see that the same way. There's this dual challenge. How do you provide the energy for prosperity, as Kamel talked about, while managing the risks of emissions? And how do you do that more effectively? Ideas to use energy more efficiently, ideas to get us on the path to a 2 degrees C world in the future, while also providing the energy. It's a tough ask, but we got to think about that in a different way than we have in the past. And the bright minds in this industry, there's a lot of chemical engineering challenges in there that I'm sure I look forward to seeing the results over the years.
Well, thank you both very much. We really appreciate your participation in the annual meeting. This makes the AIChE that much more impactful and important to our members. Thank you very much.
Thank you, Professor
Thank you very
Karl.
much.